Alright, so this video is about finding the vertices of a rhombus when given the endpoints of one of its diagonals. Or it could be finding the endpoints of the other diagonal. Either way, it's the same thing. So in this picture it says, in rhombus math, the coordinates of the endpoints of the diagonal MT are given here. What are the coordinates for A and H? So let's plot those points. M is at 0, -1, so this would be 0, -1. And T is at 4, 6, so that's 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. So this is at M, and this is at coordinate T. Because that's the endpoints of the diagonal, if I connected those dots, I would have this rhombus. Alright, well, I would have that diagonal rather. So to find the rhombus, I'll think about this. If I could find the midpoint of this segment, I could think about rotating this point 90 degrees because the diagonal meet each other at 90-degree angles. So let's find the midpoint of that segment. Midpoint formula says that you add the x's, and then divide by 2, and then you add the y's, and divide that by 2. So if I add the x's in the first coordinate, which was 0, -1. The other one was 4, 6. The x coordinates are 0 plus 4 over 2. And the y coordinates are -1 plus 6 over 2. So that should be 2. And this is going to be 5 over 2. So I'm going to make that a decimal. 2 and 2.5. So the coordinate is at positive 2 and then positive 2.5. So about right there. It's the midpoint. Alright, so the other diagonal has to go through that midpoint in such a way that it meets at 90 degrees. So I know it looks something like that. So if I rotated this point 90 degrees counterclockwise, alright, so if you remember counterclockwise rotation, if you rotated that 90 degrees counterclockwise, you have a good idea where that would be at. It's kind of hard to visualize what would be 90 degrees there. So because of that, the rotation formula for 90 degrees counterclockwise is -yx. So that's how we rotate a point 90 degrees counterclockwise, is if about the origin. Now, because this isn't centered at the origin, it's centered here. So we got rotated about that point. I need to move this point back to the origin. So I'm going to first write that coordinate. So the center is at 2, 2.5. And the process is I want to take the coordinate I have and shift it back down to the center and then rotate it. So I'm going to take the coordinate I have, which is T, which will be 4, 6. We shift it back down to the center by subtracting the x, subtracting the y from the center. That was the center from it. That shifts it back to the center. So it gives me T prime would be at, this is, some people call it fake T prime, would be at 2 and 3.5. Now, what we're going to do is we're going to rotate that 90 degrees counterclockwise. So to rotate that, the formula says it should be -y, positive x. So since y is 3.5, is -3.5, x is 2, and that's 2. Now, since I subtract from the center to move it downward, I need to add the center back to it. So add 2 and 2.5 back to it. And the first coordinate should be -1.5, and that's going to be 4.5. So the real T prime would be at -1.5, 4.5. So it would be over -1.5 and up 1, 2, 3, 4.5, roughly where I thought it should be at. Just kind of giving a guess where it should be. So that's what it would be if I rotated that way. So I know that that's one of the coordinates to the endpoints. I need to find the other coordinate. So I need to rotate t 90 degrees the other direction. Or you can think about 270 degrees around. Either way. So I'm going to take this point instead and rotate it 90 degrees counterclockwise. So using the other point M, the way I have to memorize counterclockwise and clockwise and all those, I'm going to use this point and rotate it. So to find M prime, if I rotated that 90 degrees that way, I'm going to start off with the point M at 0, -1. I'm going to subtract the center from it again. So subtract 2, subtract 2.5. So I got my fake M. That should be a -2, -3.5. Rotate it 90 degrees counterclockwise. Makes it -yx. So that makes that coordinate become +3.5, -2. And after I rotate that 90 degrees, I'm going to add back the center. So I'm going to add back 2 and add back 2.5. So it gives you 5.5 and looks to be +0.05. All right, so if I graph that point, which is +5.5, 0.5. So both are positive, so I should go over 1, 2, 3, 4, 5.5, and up about a half. So it's really on the line I kind of eyeballed to be at anyway. So if I connect to the dots, this would be the size of the parallelogram. And this would be the point M prime. Now, keep in mind, the parallelogram isn't called MT prime, TM prime. The parallelogram is really called MATH. So that T prime is really A. And M prime is really H. So I'm going to mark those off so I don't need those titles anymore. So this is the parallelogram math. And it looks to be a square. And more specifically though, let's get clear. The coordinate A was what we wanted to find. And the coordinate A was at -1.5, 4.5. And the coordinate, the other coordinate X is found was H. So I'm going to go down to M prime, and that's really H. So H is at 5.5, 0.5. That's all I have. Good luck.